This is Chapter 2, Part 4, Screencast. All right, significant figures. So let's start with going through some of these measurements. And you only count significant figures if it's a measurement. So like your phone number doesn't have significant figures because it's not a measurement. So if any of these units aren't here, then you don't have to count sig figs because they're not a measurement. We only use measurements because of accuracy and how you measure it. You can't be as more accurate than the instrument that you're using to measure it. So that's why we use sig figs. Okay, for letter A, 28.6. There's no zeros here, so you don't really have to worry about the rules. You only have to worry about them if there's zeros. So you count every single digit. 1, 2, 3. 3 sig figs. Next one, there is a zero, but when there's a decimal point after that zero, that indicates that that zero is significant. So you count all of them. 1, 2, 3, 4. 4 sig figs for letter B. Next one, 910. There's no decimal point. So we're saying that zero is not significant. So there's only 2 sig figs in letter C. Next one, 0.04604. Remember the rule, zeros in front of non-zero numbers that are leading the number are not significant. So we don't count these 2 zeros. Another rule, zero in between non-zero numbers are significant. So we do count this 0 right here. So we count 4, 6, 0, 4. That is 4 total. So 4 sig figs for D. Letter E, 0.0067000. We don't count these zeros because they are in front of the number. We do count these zeros because they're after a decimal point. So we don't count this 0 because there's no decimal point there, but we do count these zeros because it's after a decimal point. So whoever measured this put these zeros here because they said I know that this place is 0, this place is 0, this place is 0. So we count this 6, 7, 0, 0, 0. So that's total of 5 significant figures. All right, in your book, you can read through the solution again if you still don't understand, so make sure you review that. And then here's some more practice for you. I would cover this up and then try to solve that to make sure that you get it. All right. All right, and now rounding. So rounding, right here are the rules, and I think you guys are familiar with this. Greater than 5, you will round up. Less than 5, then you will stay the same. You just drop that last digit. 5 followed by non-zero digit. So for example here, you just follow like the greater than 5. So 2.78, and you only want that measurement to be like 3. Say like your calculator spit out this number, but your measurement should only have 3 sig figs in it because that's how many sig figs your beginning measurements started with. So you round up to 2.79. And then right here, you round up again you round that 3 to a 4. And then here, 5 not followed by a non-zero digit, and the preceding significant digit is even. You're just gonna keep it the same. We're not gonna deal too much with these rounding numbers because the rules are like if it's followed by a non-zero digit, then you round up. Not followed by a non-zero digit and it's an odd, you round up. And it's not followed by a non-zero digit and it's even, then you say the same. So they're really complicated that way, but we'll just deal with greater than 5, you round up. Less than 5, you just drop that number, you round down. Okay, now when you have these measurements and you have to like add them or subtract them or multiply and divide them, there's some rules that you need to know for the your answer. Your answer you have to round up or round down. And they're not as complicated as the sig fig rules, so it shouldn't take you too long to get them. All right, there's some more practice. I think we did that when we looked at the textbook and the rules. Okay, so adding, subtracting, multiplying, or dividing. So the first rule, when measurements are added or subtracted, the answer can contain no more decimal places than the least accurate measurement that you started with. So for adding and subtracting, we don't really look at sig figs, we look at how many decimal places there are. And when I say decimal places, I mean how many numbers are there after the decimal place. So if there's more numbers after the decimal place, then that means that that measurement is more accurate. So that's why I say we don't want to be more accurate than the least accurate measurement. So look at these two. Which one is more accurate? And it will have to be 5.85 because there's more numbers after the decimal place. So our answer should have no more decimal places than the least accurate number. This is the least accurate number, 97.3, and there's only one decimal place. So our answer should have only one decimal place. When you put in your calculator or do it in your head, you get 103.15. So we have to get rid of this last digit because we only want one number after the decimal place because this measurement has only one, and that's our least accurate measurement. So we're going to round because this is 5 or greater. We're going to round up to 2, so it's 103.2. So that's what you do for adding and subtracting. So when you get these problems, you look, see if it's adding or subtracting, and then you look at the decimal place. For multiplying and dividing, that's when we look at sig figs. So you have to know how many sig figs are in these measurements first. And what I do, I always make a note, count them. So there's 3 there, and there's 3 there. So this one's pretty easy. So the final answer has the same number of sig figs as a measurement having the smallest number of sig figs. So there's 3 and 3, they're the same. So there's one that's not smaller than the other. If this one is only 2, then our answer should have only 2 sig figs. So when you calculate it, you'll get 658.05, and that has 5 sig figs. We only want it to have 3. So we just get rid of 0 and 5 because we could round that up to 1, but then we'd have to get rid of 1 too. So we have 658. So that's what we do. We round for both of them, but for adding and subtracting, you look at decimal places. For multiplying and dividing, you look at sig figs. Okay, perform these calculations following the rules. So 26 times 0.02584, and do those, but I think these are in the textbook. So let's look at these problems. All right, so 5.44 meters minus 2.6103 meters. So this is multiplying, or this is subtracting and adding. So we look at the number of digits after the decimal point. There's 2 here, there's 4 here. So our answer should only have 2 numbers after the decimal point. When we do the math, you'll get a larger number than 2.83, but you'll have to round it to 2.83. See that right there? Because we only want 2 numbers after the decimal point. Then for part B, you have multiplying, dividing. So this is multiplying. We look at the sig figs. There's 2 here, there's 4 here. So our answer should only have 2 sig figs. You'll get a number that's larger than 38, but you'll have to round it to 38 because you only want 2 sig figs. You don't want to be more accurate than the least accurate number that you started with to measure. All right, so, and you can practice this. 2.099 grams and the sum, so you're adding. So you only want to have 3 numbers after the decimal point. So that's your answer. And go through that and make sure that you understand multiplying, dividing, adding, and subtracting for sig figs.